Hello again. In this lesson, we've got a lot of ground to cover, so that's why we're splitting this lesson up into two video files. So make sure you download and watch them both. C# is an object-oriented programming language. Object-oriented programming is a mindset or a philosophy of programming that attempts to simplify the creation of complex applications by relating things in code to their counterparts in the real world. Now, when you first get started with object-oriented programming, or sometimes shortened to OOP, or OOP, or just OO, you might think that it really doesn't simplify anything, but makes a lot of things more difficult. Now, in simple applications, this might be true, but as applications grow and changes are required, by applying concepts of OO to your applications makes them more flexible and less easily broken. There's actually several advantages to using object-oriented programming, and I'll try to point them out as we go along in the lesson. But like most of the topics that I've introduced in this series of lessons, I'm really going to only scratch the surface. It could take literally months or years of working with OO to fully understand it and apply it to your applications. So if this is true, then why am I introducing it so early on in the learning process to you? After all, this is only lesson 6. Well, the reason is because OOP is all around you, whether you realize it or not up to this point. In the first lesson, you were writing object-oriented code and never really even realized it. C# is object-oriented, and as you'll see in this lesson, you have to understand it to be productive in C#. Admittedly, you may not be to the point where you can fully harness the power of OO just yet, but in my opinion, it's never too early to introduce the basics because it's going to make a lot of things easier to understand after this lesson. The basic building block of object-oriented programming is a class. Think of a class as a blueprint on how to build a house. Or think of it as a recipe that explains how to create a batch of chocolate chip cookies. Or you can think of it as a sheet of music that someone can perform. In each of these cases, there's a distinction to be made. The blueprint is not a house. The recipe is not a cookie. And the sheet music is not a performance. They define how each of these should be performed or built, but it's not the same thing. You can create several houses from the same blueprint, and each of the houses is an instance of the blueprint. The color of the brick, the walls, and the carpet, they might be different, but they're essentially the same house. And you can create multiple batches of cookies from the same recipe, but each cookie is shaped just a little bit differently. But there's no denying that all the cookies were created from the same recipe. And many different musicians can perform the same piece of music, each sounding just a little bit different. But there's no denying that essentially they are the same song. That is the essence of the difference between a class and an object. A class is the blueprint. An object is an instance of that blueprint. You can create several instances of a class. Each instance is undeniably created from the class's instructions. Each object instance can have different properties, but they're all still from the same class. Now let's take a button for a concrete example. As you can see here, I have two buttons on my form. One can be small and gray, and the other one can be big and kind of like this blue color, periwinkle. But they're both buttons. It's just that each instance of the button has different properties. Do you realize that the button in the toolbox is essentially a class? And each time we drag it from the toolbox on the designer surface, that a new instance of that class is being created. And we can change the properties of each of the button independent of other instances, which makes them appear differently whenever we place them on our designer surface. But they're both instances of the button class. Now let's take a look at the form itself and notice that whenever we're defining a form, we're essentially defining a class, public class form1. And so when our application is actually run, an instance of our form class is created. You see, object-oriented programming is all around you, and you've already been working with it. Now, in the remainder of the video, we're going to look at how to create and use our own classes and objects in our applications. We're going to move kind of fast, but take everything one step at a time. So don't worry. I encourage you to also read through the document that accompanies these lessons in order to learn more about programming with classes. Okay, so let's get started by adding a new item to our project, and I'm going to make sure class is selected from the templates, and I'm going to rename the class from class1 to car.cs. I'm going to click the add button. Okay, notice that it adds a new car.cs file within our Solution Explorer, and it opens up that file into our main area. Notice that I have a definition for a class car, and we have an open and closed parenthesis in lines 8 and 9. Now, it's a pretty boring example because there's nothing defined within my class, but we've defined a class nonetheless. Now let's do this. Now that we've created a class, a blueprint if you will, let's create an instance of this car class. So let's go over here to our designer, and whenever somebody clicks on our colorful OK button, we will create an instance of that new class. So it's a type just like any other data type at this point. So car, my car equals new car. Okay, so now if we ran the application, nothing would really happen yet. But this gives me a chance to talk about the practical side of defining a class and creating an instance of that class. Now, I could also do this. I could perform both of those lines of code, lines 20 and 21, in just one line by doing this. Car, my car equals new car. All right, so this looks a lot like what we did in the previous lesson whenever we created a string array. We did something like this, right? String my array equals new array. And at that time, we said, let's just table the discussion of what the new keyword is. But what I want to do now is talk about the new keyword, because it actually does some nifty things behind the scenes in your computer's memory. But for our purposes, since we're just getting started, you can think of the new keyword as just a way to literally create a new copy of our blueprint, a new copy or a new instance of our class. It's like building another house from the same blueprint or creating another batch of cookies from the same recipe. The new instance of your class is distinct from all other instances, or rather, all other copies of the original class. But you must use the keyword, the new keyword, before trying to use or reference your new instance. If you don't, then you're going to get a nasty error message whenever you're attempting to compile or run your application. Alright, so at this point, our little example doesn't really do anything. Let's go ahead and comment out some of these things. But we're going to change that right now. We need to add some properties to our class. Now consider the button class. Let's go back to that for just a moment here. Notice that each instance of the button has a set of properties in the Property tab here that we can manipulate and modify that change either the appearance or the behavior of that given control. Now we can also create properties for the objects that we build as well. So our little car class can have its own properties that can be set. Okay? So now let's go over this and back to our car.cs file. And let's talk about the two parts of a property. First of all, there's a variable that maintains the value of the property behind the scenes, and that's called a field. And then there are the methods that allow for the accessing of that property. So there are two distinct parts, and it's important distinction to make, as we're going to talk about in just a moment whenever we talk about encapsulation. So let me give you an example of what it looks like to build a field. Here we're going to build a private field of a type string called make. So we're going to have, our car will have a make, and then we'll also have a model, and then we might also have something that keeps track of our elapsed mileage. So as you can see, I've defined a field, or actually three fields, much in the same way that I defined a variable in the previous lessons. The biggest difference is the use of the keyword private, and I'll explain what that term, that term private means a little bit later in this lesson. So these are examples of fields. Now let's take a look at another part of our property, and that's actually called property or properties. And so let's do this. Public string make. And I'm going to add two more properties. I'm just going to paste them in off my clipboard. Again, for now, let's just ignore the use of the keywords private and public. I'll talk about them at length a little bit further on this lesson. Just accept the fact that you have to use the keyword private whenever you're defining a field and the keyword public whenever you're defining a property. Now, as we said earlier, properties have two parts, fields and then also properties. A field holds onto a value behind the scenes, and the property is the public accessor and mutator for that behind the scenes value. And this is the concept of encapsulation. I'll get back to that in just a moment. But notice as we have defined the second part, the property part of the properties, that each of those have two distinct pieces. You have a get statement that allows us to return the field back when it's requested. And then you write code in the set statement to assign the underlying field value to whatever it's being assigned to. Now notice the keyword that I use here, value. It's highlighted in blue by the C# code editor. This is a generic parameter name that's created automatically for you by C#. And I'll talk about parameters in just a moment. But let's come back to this at this point and just accept this at face value. Now what I want to do within my code is use these properties back in my form1.cs. So now that I have a new instance of car, let me just delete that, I can set the properties of my car. So I'm going to do my car dot, and now notice that I have make, model, and elapsed mileage that are displayed within the IntelliSense. So for example, I could set the make equal to Oldsmobile. I could set the model equal to a Cutlass Supreme, and then we can set the elapsed mileage equal to 200,000 or something ridiculously high like that. Now just for fun, let's go ahead and set a breakpoint and watch what happens within our application. We'll run our application. I'm going to click my OK button, and I get my breakpoint stopping here, and I'm going to just select the Step Into button. And notice what happens whenever I do this assignment. Notice it goes to the set statement of my make property. It executes that. It passes in the word Oldsmobile to the make value, which is currently null, and assigns that property to make. So now when I hover my mouse cursor over, notice that it has successfully set that value. And the same thing will happen for model, and finally for elapsed mileage. The same thing is true whenever we use the get statement. So let's do something very simple. Let's just do messagebox.show my car dot make. And now let's set our breakpoint at that line of code. I'm going to save what we have and then run it again. Hit our OK button. And this time we're about to execute this line of code. I'm going to select the Step Into, and notice what it does. It goes to our make property, and it's going to return the value, our private field of make, back to the messagebox.show method, which in turn displays a message box with the make of our car object, the my car object, which is set to Oldsmobile. Okay, so hopefully that makes sense to you so far. We're able to define properties that reflect the real world properties or descriptive elements of a given object. Then using code, we're able to set the values of those properties that makes one instance of our object distinct and unique as compared to other instances of that same object. Classes not only define properties, but they can also define methods. And we've been using methods a lot in the previous 5 lessons. Every time we wrote code inside of an event handler, we've been writing code inside of a method. A method is a named block of code that can be called from another place within our code. These are sometimes called functions or procedures, but in object-oriented programming, the term method is more correct. Now, while a property describes something about an object, you can think of a method as an action that the object can perform. So in terms of a dog, for example, we might have properties that describe the dog's height, its weight, its breed, and so on. But the dog also has methods of run and jump and bark. And many times the run, jump, and bark methods depend on the property values of a dog. So for example, if the breed property of a dog is Golden Retriever, it might run or jump higher than a Chihuahua. Okay, so let's transfer that to our car example. We might have a method of our car that we call drive. A drive is something that we expect our car to do. And depending on our application, what we're trying to accomplish within our application, the drive method could mean many different things. A drive method could be used to increment the elapsed mileage property of the car, as well as calculate the costs related to gasoline consumption, the wear and tear on the automobile, and so on, from an accounting perspective. So if we were writing an accounting program, that's maybe what we would use the drive method to do. Now, before we create our concrete example of what the drive method in our car class will look like, I want to talk about methods in general a little bit more. A method can accept parameters, and these are values that are going to be used in the body of the method's code block to modify how it works. We can use practically as many parameters as we need in our methods. Here's how to define a parameter. Let's just go here to the bottom of our button to click event, and I'm going to paste in a little bit of code here that we'll look at. Let's move that over. So you can see here I've got a method, public integer add 2 numbers, passing in first number and second number. Now this is a very innocuous example where we're only adding 2 numbers together. So this isn't extremely useful, but it'll allow us to take a look at how parameters can be passed in. Notice that we can, first of all, define the data type of the parameter as an integer in this case. It can be any data type. Then we give it a name, and it can have any name that we want as long as it's not a keyword used by C#. And I can include a second parameter by merely separating them with a comma. Notice that both parameters are within the open and closed parentheses that are next to the name of our method, which we called add 2 numbers. Also notice that we've defined this method as an integer. What does that mean to create a method of type integer? Well, a method can return a value or decide not to return a value. If a method doesn't return a value at the end of executing the code block, then it's referred to as a void method. Let me show you an example of a void method that I've pasted in here. Notice public void display message. I've got a message parameter of type string, and this particular method, all it does is display a message box that shows the little message. Okay? Not very useful, but you get the idea of what void means. Nothing is returned back at the end of this. It performs its duty, and then nothing is expected to be returned from this. However, in this case, in the previous method we created, notice that we are returning the sum of first number plus second number. So when we call this add 2 numbers from our application, let's just do this. int result equals add two numbers, and we'll type in a 3 and a 5. And then we can do something like this: messagebox.show result to string. Here, we'll comment this out. Now let's run our application. Whoops. Got a little problem there. Let's run our application. And we see the value of 8. So this is how we were able to call our method, passing in values, retrieving the values, the result, and displaying them in a message box. What we could do now is, instead of using the messagebox.show, call our display message, passing in result to string. Now, what we'll get is exactly the same, because all display message does is display a message box. However, notice the two distinct ways that I used my methods. Here's a method that returns a value, which we then capture and then use later on within our application. Our void method doesn't return any value. It performs its duty, and that's all there is to it. Okay, so that's the difference between returning a value from a method and a void method. Now, alternately, what I can do, let me just comment this out and this out, is called display message. And instead of having to create the result variable, I could just do this: add two numbers, 3 and 5. This will return an integer, so I'm going to need to do a toString on the end of this. It's a little bit more complicated example, but notice how I'm able to do that in one step. I get a return value from this, converting it to a string, and then calling my void method to actually display it on screen. Okay? So those are some different ways to think about methods, how to call them, and how to use them within our classes, using parameters and also return values, or not using return values by designating a void method within our class. Okay, so now let's go back to our car class, and what I want to do is go down here below my last property. I'm going to paste in some code. Here I've created my drive method. Notice that public string, so it's going to return type string called drive. I'm going to pass in an integer of the number of miles that should be driven. What I'll do in this code is fairly simple. Here I just increase the elapsed mileage to add in the new miles that have been driven. And as you can see here from my comment, I could perform some additional calculations. And then finally, what I want to do is build the result, where I'm going to take the make and the model and the new elapsed mileage number and put them into a friendly string and return that from my method. Okay, so a method can do more than one thing. Now, it's generally best practice to keep your methods very small. So we may want to perform this in two separate steps, but just for the sake of argument, we're going to build a very simple functionality in our drive method. So now let's go back to our form 1, and let's go back up here where we had our other mycar stuff, mycar.drive, and we'll pass in like 30 more miles. Okay. Now, what we'll do with this, let's do this. String new, let's call this result. And we'll set result equal to mycar.drive. Then we'll do this messagebox.show, and then whatever result is. Okay. Okay, so now you can see the Oldsmobile Cutlass Supreme now has 200,030 miles. Okay, great. Now I can also choose to simply ignore the return value. For example, let's go ahead and comment all this out and then just call mycar.drive. And then in a separate step, we'll go back messagebox.show and we'll do something like this: mycar.elapsed mileage to string, just to make sure that the number was added in. Okay, so let's save this and let's run our application now. Okay, I'm going to get a build error which says I forgot to pass in how many miles we wanted to go. So let's in this case go 40 miles. Let's make sure this works. Now notice I'm ignoring the return string, but ultimately our method still performed. It added the 40 miles into our original elapsed mileage count, and we were able to retrieve that value back out through its property. Okay, so while we're talking about methods, I want to talk about variable scope for a moment. Every variable we define has a scope. Scope means that the variable can only be used within the context of the code block in which it was defined, or any sub-code blocks that are also defined within the same code block. Okay, to illustrate this for you in a number of ways, let's add another button to our form. Actually, let's just use the button that we've already got, and let's do this. In our button 1 click event, we'll just double click button 1. We're going to add some code here. And now let me get a reference to my car. So let's do something very simple. My messagebox.show my car.elapsed mileage .toString. Okay, can you notice first of all that I'm not getting IntelliSense help? That should be my first clue that I do not have a reference to my car anymore. That's because the my car variable is not any longer in scope. Why? Because it was defined in this code block, in the button 2 click event, and it is not global enough to be seen by my button 1 click event. Now let me do this. Just take a slightly different step here. And I'm going to move this. In fact, let's do this. Let's move this outside of my button 2 click event. I'm just going to highlight it, drag it, and drop it. And now I'm essentially making it into a field of my class, of my Form 1 class. Okay? So now when I do that, let's go back down to the button 1 click event. Let's delete all this stuff out and start over. My car, notice that it shows up in IntelliSense. I get to the elapsed mileage and the toString method and so forth. So by simply moving the definition for the car outside of the scope of one code block to a more global code block at the form level, then everything within the form can access and reference my car. If I were to put this back into the button 2 click event, I have basically reduced its visibility down so that only the button 2 click event code block can see it. And if I were to try to run my application now, I would get a build error. And we can see here that it says the name my car doesn't exist in the current context. Why? Again, because we have removed it from the context, the larger context of our Form 1 and moved it into the button 2 click. Okay, let me give you another example of this just to kind of prove the point. We're going to go down to the very end of this. And let's take a look at this selection statement. If my car.make equals Oldsmobile, then inside of our if code block, we're going to create string my model, and we're going to do something very simple here. My model equals my car.model. Then outside of the little if code block, we'll try to reference my model, the little variable we created. And what do you suppose will happen here? Do you think this will work? Well, let's try to run our application and notice that we get an exception. The name MyModel does not exist in the current context. And you can see here we have a little blue squiggly line. So this will not work. Why? Because it's been defined outside or inside the scope of a more restrictive code block. If I were to take this line of code here and move it inside of the code block, it would work. Okay, we get another exception at the very bottom because we need to get rid of this. You can see here we get Cutlass Supreme in a message box. Or if I were to do this, let's take this back out. Let's uncomment this and move string MyModel outside of the if statement and run this. It'll work as well. We'll have to initialize the value here in order to make this work. And you see that works as well. Okay? So just keep in mind the concept of variable scope. We haven't really needed to talk about scope up until this point in time, but now that we're creating methods and properties within our classes, this is a very important concept. We'll revisit scope again and scope modifiers like private and public in the next video that is actually part of the same lesson.